This is Laura Duncan from CSMS. Today we'll be talking about the applications of the Pythagorean theorem. Use the Pythagorean theorem to find the missing side length of a right triangle. Remember that the Pythagorean theorem is a squared plus b squared equals c squared, where a and b are the legs of the triangle and c is the hypotenuse, which is the longest side and the side that's opposite the right angle. The first example is finding height. So if you can highlight the right triangle, it may make it more clear that that's why we're using the Pythagorean theorem. Note that 17 is your hypotenuse. That is the most important part right now. Now the process is that we'll use a squared plus b squared equals c squared. We will substitute and solve. Some students find it helpful to list out the measurements of each side. Then we'll use the Pythagorean theorem, a squared plus b squared equals c squared, and we'll substitute and solve. B is 15, so we have a squared plus 15 squared equals c, which is 17 squared. Now let's simplify it. To simplify it, we'll simplify 15 squared, that's 225, and we'll simplify 17 squared, that's 289. Now we need to isolate our variable, the a, and to do that, we'll do the opposite. What we do to one side of the equation, we do to the other, and we end up with a squared equals 64. Isolate the a further by taking the square root of each side. The square root of a squared is a, which is what we want. We want to find out what a is. A equals 8. Well, what does that mean? Let's write the solution in a sentence. First, go back to the question. What was the question? The question was, how high is the kite? So the solution would be, the kite is 8 meters high. Remember those labels, folks. The second application is finding the distance between 2 points. To do this, you're given a grid. However, you need to be able to highlight or draw the right triangle. Now, we're not given the lengths of each side, so we'll simply count to find out the lengths. 1, 2, 3, 4. This side is 4 units long, and this side, 1, 2, 3, 4, 5, 6, is 6 units long. So reviewing our numbers, A is 4, B is 6, and we're finding the length of the hypotenuse, so we don't know what C is. We'll begin with the Pythagorean theorem to find the distance between these 2 points. A squared plus b squared equals c squared. Then you will substitute and solve. So we substitute 4 for a, so we have 4 squared plus 6 squared equals c squared. 4 squared is 16. 6 squared is 36. The c squared is already isolated, so we simply have to combine these terms. So 16 plus 36 is 52. That's equal to c squared. Now let's take the square root of c and the square root of 52. What you do to one side, you do to the other. Please round your answer to the nearest tenth. Now let's talk about the solution. It should be written in a sentence form. So the question is, find the distance. The distance between the 2 points is 7 2/10 units. Let's do a quick review of page 1. So when we're talking about the Pythagorean theorem, we're talking about a way to find height and a way to find distance. Let's look at number 3. Another way is to find the length of diagonals. Jose wants to hang lights on his ceiling in the shape of an X. The ceiling is 30 meters by 40 meters. How many meters of lights does he need? You may have a hard time seeing how this is related to the Pythagorean theorem until you highlight a triangle. So notice this is a right triangle. Therefore, we can use the Pythagorean theorem to find this length, the length of one diagonal. Notice there are two diagonals, so we will have to think about that later. But for now, the length of one leg is 30. The length of the other leg is 40. So A is 30, B is 40, and we're looking for C. Let's begin using the Pythagorean theorem, which is a squared plus b squared equals c squared. Then substitute. We have 30 squared plus b, which is 40, plus 40 squared equals c squared. So 30 squared would be 900, 40 squared would be 1600. We're trying to simplify this problem. These are on the same side, so let's combine them first. So 900 plus 1600 is 2500. 2500 equals c squared. Let's isolate this c by finding the square root of both sides. So c is equal to 50. Now let's go back to our problem. We found that c is equal to 50. That means this side is equal to 50. That's called a diagonal. That would be one strand. But remember, Jose wants two strands. So since one strand is 50 and he wants two, we will multiply by 2 or add 50 twice. And that would be 100. Go back to the question. How many meters of lights does Jose need? Jose needs 100 meters of lights. In number 4, we come to another application. This application is how much wire is needed to support a utility pole. The most difficult process for 8th graders is to know where to put the numbers. So read very, very carefully, and it should become more clear as you do more practice. Let's begin by reading the question. A utility pole 12 meters high is supported by 2 guy wires. Each guy wire is anchored 4 meters from the base of the pole. How many meters of wire are needed for the guy wires? You may end up reading a question 2 or 3 times. That's okay. That's what math teachers do as well. So let's look at the utility pole. It is 12 meters high. Well, it's height, so you don't measure height when you're laying down, right? You measure height when you are perpendicular. So this 12 is the height of the pole. The next section, each guy wire is anchored 4 meters from the base of the pole. Well, just think about it. Is it talking about the length of the guy wire, or is it talking about how far it's anchored from the pole? It seems to be the second choice. So we'll label that as 4. Now go back to the question. How many meters of wire are needed for the guy wires? So does it seem like they're asking about this? If it is, then we probably have our dimensions in there correctly. All right, where's your hypotenuse? We're looking for the C. So let's substitute our numbers. We can have A is 4, B is 12, and we're looking for C. So we'll start with the Pythagorean theorem, a squared plus b squared equals c squared, and we'll substitute. So we'll have 4 squared plus 12 squared equals c squared. We'll simplify and solve. 4 squared is 16, and 12 squared is 144. And that's equal to c squared. These are on the same side of the equal sign, so we simply add them together. Now we'll do the opposite of squaring a number. We'll take the square root, and c is equal to 12.6. Now look at the solution. The solution says estimate your solution to the nearest whole number. So I want my final answer to be a whole number, but I would encourage you not to round until you get to the end. So let's take a look back at the beginning of our problem. We know that one guy wire is equal to 12.6, but 2 guy wires are needed to add stability. So we'll have 12 and 6/10. We'll multiply that by 2. So about 25 meters of guy wire is needed. Let's turn to the last page of notes. In this, you'll have like missing pieces of a puzzle. You have a picture, you have the use of the Pythagorean theorem, you have work, and you have your solution. Let's begin with the picture. We have 7, 24, and x. You need to figure out which one is your hypotenuse. Now use the Pythagorean theorem, a squared plus b squared equals c squared. If you notice a triple, you may always use that. Now if you notice a triple, then write the triple in your work section. I'll be working this out with you. So a squared, a is 7, b is 24, and we will begin showing our work. So 49 is 7 squared, 576 is 24 squared, and we're looking for c squared. We'll simply add these two terms together because they are like, and we have 625 equals c squared. We'll take the square root of each side so that we find that c is equal to 25. Since there are no units on here, our solution is simply 25. So that was a triple. It's 7, 24, 25. Please pause the video and try the next column on your own. Take a moment and make sure that you substituted your sides correctly. Check your final answer, and now let's go on to column 2. Notice in column 2, we're not given the same information. This time, we are given the work. And they give us the answer in this form. X equals the square root of 144. Well, is X the A, B, or C? So let's look at X equals 144. The solution to X equals the square root of 144 is X is equal to 12. So we have one side of our triangle. We just don't know which side it is. As we go back, we're going to use the Pythagorean theorem. So let's go back up to this point where we use a squared plus b squared equals c squared. Well, if we match it up, we see c squared is going to be right there. So c squared is 169. A squared is equal to 25. Well, let's work backwards. If a squared is 25, then what is a? You would have to find the square root of 25. The square root of 25 is 5. So 5 squared plus b squared equals c squared. Well, what's the square root of 169? That would be 13. Now we have the three sides of our triangle. The C is the largest side, 13. Now, as you're drawing this triangle, remember, it doesn't matter where you put your 5 and your 12. That's a triple, 5, 12, 13. Let's go on to the fourth column. Looking at the fourth column, if we start here and write a squared plus b squared equals c squared above it, it may make it more clear which number is your A and which number is your B. And hopefully you can tell that C is not given. So draw your triangle. One leg is 18. One leg is 24, and you are looking for your C. Let's go to the highlighted section where they have not finished this equation. So we simplify. 900 equals x squared. We take the square root of each side, And the square root of 900 is 30. So 30 equals x. That's our solution. Let's look at the last column. The last column is the most challenging, and therefore it is the most rewarding. We know that one of our sides is equal to 10. We just don't know whether it's A, B, or C. What we find out from this column is that we have two perfect squares that add to 100 or two perfect squares that subtract to 100. So first, let's list out the perfect squares. 1 squared equals 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. 8 squared is 64. And 9 squared is 81. What we're looking for are two perfect squares that add to 100 or two perfect squares that subtract to be 100. Let's first look at the addition. Do you see the two perfect squares that add to be 100? Pause the video if you need some time to process this. So the two perfect squares that add to be 100 are 6 squared and 8 squared. Those two add to be 100. So we can work backwards here. We know that 36 plus 64 equal 100. Well, let's work backwards some more. The square root of 36, going backwards, would be 6. The square root of 64 would be 8. So 6 squared plus 8 squared would be equal to 10 squared, which is our c squared. Now let's go back and fill in our information. This means that one side is 6 and the other leg is 8. Let's fill in our final grid of a squared plus b squared equals c squared. And the lesson is yours.